I'm going to unmount the Orion's potentiometer and power switch assembly, which is this part over here. And all because I can't get the power switch to work or to react in any sort of way. And actually the power switch is that black part down below here. It's a double poled switch, and well, as far as I can tell, and it simply doesn't work whether I twist the potentiometer's axis in any direction or try to push it or pull it. It simply doesn't work. So there's obviously something wrong with it. Now what I did was I made a picture of this assembly, and then I annotated, or rather marked on the picture, where all the connections are. As you can see over there, I drew circles around the spots that are connected on the picture. So with the help of this detailed picture and a lot of patience, I think I can disassemble this to get a better look at it. I unsoldered all the wiring leading to the potentiometer and the power switch, so now I'm going to unmount the whole assembly. I unmounted the whole thing out of the chassis, and it's still pretty dirty, as you can see. You can tell for yourself this potentiometer setup is, well, quite beaten up and quite dirty. Now there's no way of telling what went wrong with it, so I will need to open it up one way or another. Now, funnily, there is this kind of strange thing about it. That is that down below here is the AC switch. Now, I don't know if you can see it, but I think you can. Right here, where I'm pointing at, is what looks like a little screw, which is holding back or together this corner of the power switch. Now if I reverse the potentiometer assembly, you can see an identical screw here. Now that's okay, but the other corners, namely this corner here and this corner over here, yeah, are riveted together. So there's no screw there, just a rivet, which is pretty strange if you ask me. Now, okay, what I'm going to do right now is I'm going to clean this off a little bit. I'm going to take a few measures of the potentiometers. According to the schematic, one should be 1.6 mega ohms, the other should be 1 mega ohm. So we'll see if that comes even close to that. And then I need to figure out what I'm going to do with the switch. I measured the potentiometers and they seem to work, although their values are not as indicated on the schematic. In fact, there are a few more values which do not fit the schematic. Namely, this capacitor here is marked as being a 2.5 nanofarad, whereas on the schematic it's indicated as 25 nanofarad, and this is a 2.5 nanofarad. Also, this resistor here, this dog bone resistor, is marked as 100 ohms, and I measured it, and it comes out at about 97 ohms, so which is pretty close to the indicated value. But on the schematic it's written that it should be 100 kilo ohms, not 100 ohms. So that's another weird thing. Then this top potentiometer measures about right. It's about 1 mega ohms, which is what the schematic indicates it should be. But then this potentiometer, which should be 1.6 mega ohms, measures more like 850 kilo ohms. Now, that being said, I know by watching many videos and reading all sorts of blogs on the internet about radio restoration that there were quite a few factories that made changes to the chassis even while the radio model was in production. So I wouldn't be astonished if while they were producing this radio, some engineer or other changed his mind and changed quite a few values. Or maybe at the time certain values were simply not available and they had to make do with what they had, and so made a few changes while producing the radio. All those possibilities do exist. So I know that situations like that did arise in the past. So I'm not alarmed yet by these diverging values. Now, as to the AC switch, now that's proving to be a lot more problematic. I tried to unscrew one of the screws, the corner screws, this one namely, by inserting a fine screwdriver into the slit sideways, into the top slit of the screw sideways, and then twisting it sideways like this, which works up to a certain degree, but although the screw head turns around, it doesn't move up or down either way. So I'm a little bit stuck with this screw, or rather with the switch. I don't know what to do with it. Now, I'm afraid of damaging it, and since I said that I wanted to keep this radio as original as possible, I need to come up with a solution for opening this switch case without damaging it, and then I still need to be able to mount it back onto this assembly without damaging it. So that's going to prove a little bit challenging, to say the least. Anyway, it has the... I'm going to restuff the electrolytic can. I finally got the capacitors I was waiting for, which are 47 microfarad, 450 volts capacitors. Granted, if you read the can, 400 volt capacitors might have done the same job, but I thought, well, since the size is rather small of these capacitors, it really doesn't matter. So I bought a slightly higher voltage rated capacitor, just for safety's sake. So that's what I'm going to do right now. Build in back the original, ready to be mounted inside the can. I tested it out first, and side by side they are just a little bit less wide than the diameter of the can, so they will fit nicely and snugly inside the can. I will wrap them in a little bit of foam rubber so that they don't rattle inside the can, and that's it. And then I'm going to crimp back the edge of the can over this cover, and that will be it. Then I will solder the two positive leads, red and brown, to the tabs, and I will solder the mass wire to a soldering tap inside the radio, and that will be it for the electrolytic can. You remember my mini drill? There was actually a plan, you see, to repair this mini drill, because like I said, I really need it, and I'll show you why. You remember the potentiometer assembly that came out of the Orion? Well, let me do a short recap. So it consists really of two potentiometers, one up here and one in the middle here, and then the on-off switch, the AC switch, down here in this little box. Now I can't make it work, the switch I mean, either by trying to pull or push the axis of the potentiometers, or by twisting them either left or right. I just can't make the switch go over. So, well, before I place this back into the radio, I thought that I'd try to loosen up this little box here, in which I suspect the AC switch is located, just to have a look. You know, maybe I can repair it, or well, maybe I can't. But if I can't take a look inside, I'll never know. Now, before I go inside the little box, I need to figure out how the whole thing is attached. And if I, you know, there are two screws on top. You see one here. I don't know, it's rather small. Let me make a close-up so you can see. Okay, so there's a little screw up here, you know, and then there's one up there, you know, so there are two screws, and somehow I seem to think that they are used to bolt the switch up to the whole assembly. Unfortunately for me, when I try to turn the screws to release the switch assembly, they just keep turning and turning and turning, and well, that is problematic. So if I can't find a way to release the switch without having to do anything mechanically to it, I mean except for turning the screws, then I will probably need to grind out 2 rivets, one here and one here. Now the thing is, if I grind those rivets out, I'm not so sure I can attach the switch back to the whole assembly. So that is rather problematic. So I'm feeling a little bit, well, I feel a little bit dubious about the whole operation. But if I can't succeed in repairing the switch, then I'm afraid I'll have to put this back into the radio as it is and find another way to switch the radio on and off. And okay, I've been looking around on the internet, and it was impossible to find an identical assembly to this. So I could try with another model, I suppose, and try to adapt another model to the radio, but I'm afraid it would hurt the authenticity of the radio, and also I might even have to do some changes to the buttons so that they would fit a new potentiometer assembly. And I'm really rather reluctant to do that. So yeah, the options are not too great. So let me see first if I can release the switch enclosure by finding a way of releasing those screws. If not, it'll be plan B, and using my mini drill to grind out those rivets at the bottom. Okay, well, I grinded the rivets out with a tiny little steel ball grinder. It's really small, so I don't know if I can show it to you. Hang on. So there you go. So this tiny little ball grinder here on the top of my nail is what I used to grind out the rivet. Okay, and it was rather straightforward. I just had to apply enough pressure, downward pressure, onto the rivet. Now, strangely enough, the rivets are really part of those screws, which I showed to you on top. Yeah. So apparently these little screws double as rivets, and in fact, if you take a look at the other side, so here, let me take a pointer. So you see the remnants of one rivet here, and then the other rivet here. Yeah, so here. Now, if I turn this like that, you can see that the remnants of the rivet here is in fact, or has in fact, a screw head up here. Now why that is, I have no idea. It's a pretty strange setup, so I would need to find out or take a closer look to see why they did it like that. Anyway, the top plate of the switch, or the bottom plate of the second potentiometer, is part of the housing of the switch. Now you can see that if I rotate the inner shaft of the potentiometer, so this shaft here, if I rotate that shaft, then that little lever you see at the bottom rotates along. I'm trying to give you a good view on it. Let me see. So it's dark on dark, but okay, I think now you can see it. So you see, if I turn the potentiometer, that little lever which you see here, this one here, yeah, moves back and forth, as you can see for yourself. So it moves back and forth, you see. Now what that lever does is, if you take a look inside the switch, yeah, and I'll let me take the camera in my hand to show you. So if you take a look inside the switch assembly, the very first thing you see is this little triangular piece here, this piece, and this piece actions the switch contacts you see down there, yeah, by simple lever action. So if I switch the triangular piece down like this, well, you see this piece moved in clockwise direction. So this brown phenolic piece of plastic here. Now that let me see if I can show you the action without hiding it from you. So if I take a pincer like this and I move it like this, it's kind of hard to do with one hand. Okay, this won't work. Okay, hang on. So let me show it to you like this. So if I move it up in that direction, there you go. So you see, by actioning that little piece of plastic here, I can make the contacts move back and forth. Now, for one reason or another, for an unknown reason, this little lever up here should fit inside that little piece down here, one way or another, and should action the on-off switching, and that doesn't happen. Now I suspect somebody in the past must have overpulled it, and therefore well, in effect breaking the switch, yeah, that disabled the switch for good, and unfortunately it disabled the switch in the off position. So what I am left to do now is find a way of replacing these little rivets I drilled out or grinded out to be able to replace this switch. And before I place it back, I'll give it a cleaning with contact cleaner and all that, because you can see it's quite oxidated inside, so it's corroded. So I'll clean the contacts first, and when I'm done, the reason why the switch didn't work has everything to do with the little cap that was on the end of this. You remember the little cap which is supposed to work in combination with the little triangular piece here. Yeah, it fits inside of there, and by turning it left or right like this, yeah, you can move this little piece, and therefore by moving this you move the whole switch assembly. Now it turns out that the little cap which I'm holding in my fingers was mounted on top of this axle here, yeah, which, as you can see, has also a notch. So if I turn over the axis, you can see the notch move as well. Now I figured out that if I am ever going to be able to move the little lever mechanism, then I'll have to mount this little cap on top of the axis in that direction. Now normally inside the cap, inside there, right inside of this little cap, there would have been a little notch sticking out, which would have fitted into the notch on the axis here. But there isn't any. Now I'm left with a few, how should I say, options as to how to attach this to the notch on the axis here. Well, the most obvious one is, of course, making use of glue. I'm thinking of super glue, or perhaps even epoxy glue. Why not? But using glue would be rather permanent. So instead of immediately trying to use a permanent solution like glue, I'm going to use a little bit of aluminized paper, which I'm going to try to squeeze between the cap and the axis on top of the potentiometer. So I think you can see it just here, yeah. So the way I need to attach it is with this little pin sticking out away from the camera. So let me see. Let's give it a try. I can still disassemble the whole thing afterwards, should it not work out. Oh, by the way, I enlarged slightly the holes where the rivets used to be, and I'm going to use very small M2 size stainless steel screws, which I will cut to the proper length, in combination with small nuts which will go on top of the screw. Yeah, so I can close up the box of the switch that way. Okay, so let's see if this will work out. Okay, here we go. This is a piece of aluminized paper. So the excesses of the paper I will cut away by making use of my surgical knife, which is extremely sharp, as you all know. There you go. Okay, so that's step one. Now let's cut the excess away with my surgical knife. Okay. I need some light in the right spot. Okay. There you go. Righto. There you go. Okay. Okay. So now the question is, of course, is it solid enough? Well, that we'll only know if we try on the cap and see whether we can action the switch with it. So let's see. Okay. So it sounds good. Not so good. See? Okay. So no, that is a no-go. So obviously we'll need something more solid to solve that little problem. So let me have a moment to ponder how I'm going to solve the problem. Okay, I reassembled the potentiometer and switch assembly, and okay, granted, those nuts and bolts, or that nuts and bolt solution, it doesn't look too original, but well, it was either that or gluing back everything. And then, you know, just as well as me, that gluing things makes them sort of permanent. So I did the next best thing, and I used some screws and bolts. Some screws and nuts, I mean. And the switch works. If you listen carefully. Okay, hang on. Hang on, I need to put that out of my hands. So if you listen carefully, you see? Okay, so how did I solve that? Well, you remember that little black piece with that little tip or that little lever on the end? Well, I cut a tiny opening with the grinder, you know, with a grinder head. I cut a slit into the side of it, something like this. Yeah, I drew a picture, and the tip of the lever would be here, really, on this side. So that's how it looks inside. So I grinded an opening here, which is as wide as the slit which was cut, the notch that was cut into the axis of the potentiometer. And then I put a tiny sliver of wood which I cut into a wedge shape, both inside the metal axis and sticking out just along the edge of that little cap. And when I was done doing that, I just melted a tiny little bit of black tar around the opening to seal the wedge into place. And it seems to have done the trick. I used wood, well, first of all because I had it handy, and second of all because wood can be shaped in any kind of shape you like easily, and also thirdly because wood is a perfect insulation against electricity. So it insulates marvelously. So those were the reasons why I used a combination of black tar and wood to solve the problem. And I think it works pretty good. So now, there it is, back in its rightful place, and all the wires soldered back to the potentiometers, ready for use. I also temporarily connected an AC wire, but this is not the, let's say, the right style of AC wire, but we need one to test it out, so that's what I did. I connected temporarily a modern AC wire for testing purposes. Okay, so what do I need to do now? Well, I need to connect and mount back the ferrite antenna on top of the chassis. So that's next. There you go. The ferrite antenna is back in place. I also took the opportunity to clean up the IF cans. As you can see, they are quite nice now. Aluminium cases, of course. So after a while they will probably start to oxidize a little bit. But it serves as it is right now, and if I'm really happy with how the radio functions and how the case, the cabinet turns out of the radio, then I might disassemble the IF can covers and the electrolytic, well, the ferrite antenna from the electrolytic, shine them up again to mirror finish if possible, and then give them a coat of lacquer to protect them. But that's all for later. So the ferrite antenna is connected. So now the only thing I need to do is put back the vacuum tubes and check that one floating high frequency coil connection and see to which pin on the band selector it needs to be connected. Okay, I connected up the Orion's chassis to the AC, in fact to the varactor over there behind the light stand, and in a minute after I reinserted all the tubes inside the right socket, I'm going to fire up the chassis for the very first time. Okay, well, the tubes are back in place, and well, like I said, it's connected up to the variable power supply over there. So in a minute what we're going to do is to switch it on and then bring the AC voltage slowly up, just to see whether there are no obvious faults in the chassis, like shorts or things like that, or things that I might have missed. Yeah? Inside the chassis, and hang on, I need to find my pointer. Inside the chassis, and more precisely over there, is the small dial light. It's a 6.3 volts, 300 milliamps light bulb, and it's the original one. It's a tungsram. By the way, some of the tubes on the chassis are also tungsram tubes, like this one, more precisely. And another one, I think it's the Easy Rectifier tube over there, which is a tungsram. And the others, I don't know. I think there's a Phillips amongst them too. Okay, so anyway, what I'm going to do, like I said, is I'm going to bring up the AC voltage slowly, and then I hope to hear some sound coming from the speaker right behind the chassis. Well, what do you say? Let's start with it, okay? So, I repaired the AC switch, the on-off switch, which is actioned by this axis here. And, well, it'll be a double test to see whether the AC switch works and the rest of the chassis, in fact. So, here we go. Turning up the voltage to roughly 50 volts AC to start with. Okay, so here we go. Okay, well, volume is at maximum right now. It's not a hot chassis, so in theory at least, I should be able to touch the chassis without hurting myself. Okay, so, well, like I said, I'm at 50 volts AC, and, well, I'm not seeing anything. No tubes lighting up, no nothing. Okay, so let's pull up the voltage a little bit. I'm at about 100 volts right now. Still nothing. Okay, so technically speaking, I should be seeing a slight glow coming from the filaments inside the tubes, and I'm not seeing anything. So let's switch the radio off and have a look. Now, I forgot to check one other thing, and that is that in the radio there is a fuse, in fact, which is a rarity apparently amongst those radios from that era. But well, strangely enough, the build of the chassis itself wasn't of excellent quality, but the builder or the architect or the designer or the engineer who designed this chassis did think about placing a fuse inside the chassis. So let's check the fuse. Okay, so the fuse is right here. So let me pull it out. Don't worry, I removed the chassis from the AC, you know, because I'm not tired of living yet. So, okay, I removed the fuse, so now let's see whether the fuse still measures out correctly. Ah, I think we have the culprit. Yeah, the fuse is dead. Okay, well, this fuse, the original fuse, was dead. I measured it on the multimeter, and well, yeah, it was dead, completely gone, finished. So yeah, that's not too good. But I placed a replacement fuse in it, which is rated for 200 milliamps. That's about the right value, I think, I hope. So, well, let's try and give it another go. So, okay, I'll pump up the voltage to about 50 volts, like that. Okay, so now I'm going to switch it on. Let's see. Okay, it's on. But I'm not seeing any kind of glow of filaments. Okay, so let's pull up the voltage to about 100 volts. Ah, yes. Now I can see some filaments glow. Very faintly, but they are glowing. Obviously you can't see anything yet, but I can tell you that I see at least 2 tubes glowing and maybe even a third one. Oh, okay. There's something wrong with the rectifier tube. In fact, I think the rectifier tube is gassy, because I saw that telltale blue flash inside of it. So hang on, I need to see if I can replace it. Okay, amongst my stash of vacuum tubes, I found an Easy 80. This is the old one, which is a Tungsram, like I said. And I found another one, which I put inside the radio. It's the one over there, alongside the transformer. And the filaments are glowing. And as you can see, there's still no smoke or anything coming out of the radio, which is a good thing. So, but I'm still only roughly at 90 volts AC or so. So, well, I still can't hear anything coming from the speaker either. So, I'm going to turn up the AC voltage to roughly 150 volts. Let's have a look. I can tell you that most filaments glow, so that's okay. Hang on. Here we go. Okay, that's 150 volts. And now the filaments all start to glow more readily. And I can tell that most filaments do glow a nice orange. Not very, very bright, but still. The dial light, on the other hand, doesn't give anything. No glow, no nothing. Can't hear anything coming from the speaker either. So, can't hear any noise, can't see any smoke. So, let's turn it up. Okay, I should be close to 190 volts now. Yes, now we have a hum coming from the speaker. Okay, that's a sign of sorts. Let's see now. Trying to tune in on something, but nothing, just a loud hum. Oh. Oops, that's not so good. Hang on. Hang on. Okay. Well, when I touch the potentiometer, there's another kind of hum. But tuning the radio doesn't make a difference. I still don't see any smoke coming from the chassis or anything. So just a very loud hum. The tone potentiometer works well, so that's okay. Volume is at maximum, but I can't hear anything coming from the radio. Except hum, of course. Okay, mind you, I'm still only at 190 volts or so. So it's possible that if I turn up the voltage, it might start to work correctly. I'm going to turn down the volume though. Okay, so here we go. Full voltage. Okay, now we are at 220 volts. Nope. A very loud hum. Yep, just a loud hum, but no stations. No matter what frequency band I try, I can hear a slight crackling when I tune, but that doesn't mean anything. Okay, let me see. Maybe if I connect up an antenna, things might improve a bit. Well, it's not exactly an antenna of sorts, but it's a piece of wire. But who knows? No. Well, the amplification stage works, that's a fact, and it seems to work rather well, but the tuning mechanism, not so much. Tuning it doesn't seem to do much, so I'm afraid it's back to the drawing board and try to figure out why we're not getting any sort of tuning and why the only thing we can hear is a loud hum. Also, like I said, the dial light doesn't seem to work, so we have to fix that as well. So there you go, the first firing up of the Orion chassis. All it gives us is a loud hum, and that's about it for now. So what we do know is that the amplification is okay, the tone potentiometer works fine, and let's see if the AC switch works. Yep, and the AC switch repair worked out fine too. So yeah, all that seems to work fine. So now, well, like I said, it's back to the drawing board and trying to figure out why we are not able to tune in anything. I fixed the dial light of the Orion radio, and well, there you go. This is the original light bulb, shining in all its glory. Of course, nothing has changed really in the working of the radio, but I didn't want to omit the view on the chassis with its very own dial light shining. So this is truly, really the end of this episode.